Welcome back, students. In this video, we're going to cover the study guide for Module 2. Now, just a early warning in this video, I printed last year's, and so this will have a couple, let me think, either 3 or 4 more problems than what you have. So if you get to something you're like, this is not on here, this is extra. Now, this is, I'm doing this after we've taken the test. We have a few of you guys that needed the extra time, so I'm hoping you'll watch this video over the weekend. Depending on how long this takes, I may split it into 2. I'm not sure. We'll just see. I'm gonna try to really explain these angles and stuff. We're having some difficulty, so I'm hoping this will help. So let's see. Hang on 1 second. Okay, sorry, I was using the the HoverCam app, so this should be a lot better as far as the picture. It's not gonna fade in and out as much. I'm not sure how the sound will be. So any of you guys that have watched and listened to the previous videos, let me know if if it's any better or worse. Just curious. I'd like to make them as as decent as possible. Sorry, I apologize. My daughter is at the ER and she keeps texting, and I keep saying I'm trying to do a video, and anyway. So Module 2 study guide. We're going to start number 1. Let me grab a couple of different colors here. So in the figure, CA and CE are opposite rays. So CA goes this way, CE goes that way. CH, so I'm going to do these in different colors. Let's see, CH bisects GCD. So CH bisects these two. So let's just do this. CH, we'll make it red because it bisects. So I realize we may have some new, I might have some new folks watching. Sorry, goodness, who in the heck is? Sorry, motion at my front door. It's a little late for that, but that's my car. Sorry again. You guys are like, man, I'm tuned in for geometry. This bro's talking about whatever. So, excuse me. All right, so I put that, but I want to say, this is what drew my mind to it. Sorry, my brain's all over the place. So bisects. So yeah, just to kind of catch up on a few things. So in geometry, the term bisect or bisector, it refers to something that cuts. So this cuts this into 2 equal angles. If they were talking about a line, it would cut it into 2 equal lines. But for this, it bisects this angle. I flipped the actual colors, but so CH bisects this angle, and GC so GC bisects BGD. So BGD, the big angle. Let's just do this. We'll make these 2. All right, and they're doing all this, and that's great, which that gives me a chance to say, bisect. So it's cut into equal or congruent, but remember in geometry that's the same thing. Let's see, what is wrong with the light? On the spot editing, and I'm there we go. Sorry about that. Maybe that will work better. Let me try a couple of different things here in a minute. Need some some help editing, or my son was helping me with the lighting. I mean, not lighting, but the sound. If you guys watch any of last year's, especially I think Module 3, you'll see, or you'll not hear me talking because I don't know what was going on, but at least he was watching last year to tell me. So anyway, so they're talking about all this stuff, and that's great, but they're not going to ask you about that. This is one of those, what I like to call football plays. Excuse me, I'm sorry. The so the offense gets to the line here, and they're running all sorts of motion and crazy stuff, and they're just gonna hand the ball off. It's all a bunch of, what do they call, window dressing. So all that stuff to ask this question. So let me find another color, because I'm gonna need it. So which angle is congruent to GFH? So GFH. GFH is right here. And I'm going to color this in a little bit and wait a second for you folks to kind of think about this before, the ones of you that don't know the answer. So a lot of you guys have already done the review, but this is kind of a going through it again sort of thing. So they ask which is congruent to this. All right, well, we have a mark here and a mark here for these guys, and a mark here and a mark here for these guys. So that's why I said all this motion over here, and they're asking about this stuff. Well, we have talked about more than once about something called vertical angles. And vertical angles, let's just put vertical angles here. Vertical angles are created when two lines intersect each other, so they make an X. And it doesn't matter how it goes, and I'm trying to think of something visual I can bring to class, but the more you go out, so this would go out and this would go out, these would get smaller. So it doesn't matter what it looks like. Anyway, vertical angles are like this. Let me hold on. Vertical angles are like this. So the ones across from each other, so up and down or left and right, are congruent. I'm going to make the up and down blue because they're congruent. And I'm going to make the left and right pink. I'm not sure. I'm always, this looks a little better than the other camera. I can kind of see my color a little better. So, all right, so the pinks are congruent, the blues are congruent. So anything across from, I always say on top of each other or next to each other, but either way across, those are congruent. Just going to do congruent, and where'd the blue go? Huh? And congruent. So blue is congruent to blue, pink is congruent to pink. So back to our problem over here. This, if you notice, looks like this. So the orange here would be like the blue. It's the same. It's the top of these vertical angles. So to be vertical with GFH, the one across from it, it would either be CFD or DFC. Let's see, I don't see a CFD, but DFC. See that right there. Let me color it orange. DFC, or you can circle it, or whatever. So the oranges in this case would be congruent, and let's make the other side brown. Maybe that's not too close enough in color that. So you'll see in this case, so the oranges would be congruent, the browns would be congruent. I don't know if you guys have heard my analogy in class, but the ones of you guys that are kind of struggling a little bit with the algebra, remember the number with the variable, so the 3x, that's a guy holding an orange, and just the the 6 or the -4, or let's scooch down. Let me find the first formula, or not formula, but yeah, so down here, so your 8x would be your guy with the orange, and the -8, that's a guy holding an apple. 7 is a guy holding an orange. -2 is a guy holding an apple. You can't combine apples and oranges, guys with apples and oranges. So back up here, the oranges go together, the browns go together. All right. So number 2, and this is one of those that was removed because it was not on the test, but this is something that you need to know, because as we get into new stuff, especially starting in like module 4, you're going to need to be able to pay attention to like linear pairs. So number 2 in the figure, so we got CA and CE, opposite rays again. CH, so let's do this right here. CH bisects these two angles. CH bisects that angle and makes these two. Sorry. So it bisects GCD, so it makes GCF and FCD. All right, then GC. Too many letters sometimes, man. GC. So it bisects this angle, FGB or BGD. Sorry, they went all the way there. So you see, you can name these things. So yeah, this guy, bisects this guy. And of course, this is the other football play. So now they're motioning on the right side, and it's gonna run a quarterback sweep to the left. You folks that don't watch sports are like, bro, will you just talk about the geometry, please? All right, so which of the following are linear pairs along the line containing AE? So let's see. Trying to think how to make it the most visible. We'll just do this. So AE. Okay, so AE, that's that whole big line. So they want to know what linear pair. And I know I actually brought the calculator home, but did I bring the compass and protractor? And I don't think so, dang it. Well, that's all right, we're going to do this. Well, you can see the line it's highlighted. So remember, linear pair. And in case you can't remember, so linear pair means it's a pair of angles from a straight line. We'll say straight angle or straight line. So being linear. All right. So before I even look down here, because it says select all that apply. So it has to be two angles together. So let's see, so FDE and FDC, you see both sides of this guy are along this line. So these two would be a linear pair. So let's keep going. The only way it would, like, because this is further away, well, actually, you'll see. So these two are a linear pair. I'm going to come back. Now these, you see how close these are together, this and this. So this line doesn't go all the way here now. It stops here. So these are two angles. Those are not a linear pair. It would take all three of these angles to make 180 in this case. Let me see if I can make this. I'm going to go above it with the blue. So blue to blue. 180. So remember, a half a circle is 180. This is terrible lighting, bro. Or just terrible writing here. Anyway, So this whole thing is 180. So this is not a linear pair. It's a linear trio that takes three of them here. Excuse me. But then we go here. So we've moved on. And this side all the way to here. So you have to be able to just have two angles in your little half a circle. See? Half a circle here, I have these two angles. So check. Half a circle here is 1, 2, 3. So no. But here, 1, 2, so check. All right, so we're looking for like a, let's see, EDF. So here's an EDF. Let's see, other FDC, FDC. So check. Or this, it doesn't matter. Okay, so, all right, what else we got here? Let's see. Well, here's B over here. B would be in the middle because it's the vertex. So it would either be like AB. Let's see, ABG. Oh, wait a minute. That's right above what I wrote. Okay. GBC. See, but B was in the middle of both of these because it's the vertex. It's the point. So the vertex of each of these angles. So yes, this is for sure one. Okay, let's see. B, C, G. Well, see, this is getting over into this mess, so no. All right, down here, D, C, F. So that's again into that mess, so no. And then last, G, F, C. So G, F, C, and D, F, C. Okay, well, all right, so interesting fact here. So let's look at these, GFC and DFC. DFC, GFC. This is a linear pair, but it's along this line. See, these two angles make the 180. So we're going to put over here linear pair, but not for line segment AE. So this, again, this is just bonus info. This was not on the review. And then lastly, BCG. So again, that's wrapped up in this mess here. So no. And I hope you understand. Again, 1, 2, 3 angles to make 180. That's not a linear pair. A pair is two angles. All right, moving on. Otherwise, we will be here all night. Or I will. I mean, you guys will be watching whenever. I am late Friday night. All right, in the figure. This is back to one that's actually on the review. So in the figure, CA and CE are opposite rays. So CA, CE, or yeah, is that right? Okay. CH. So CH bisects these two angles. I'm just doing it there. It's an arc here and an arc here, but so it bisects that angle. So that's why that is. And GC bisects these two angles, or that angle to make those two angles, excuse me. Okay, now the measure of BGC, so this is going to be 1/2 of this, so this guy over here, so it's, I'm going to write it sideways, so 7x minus 2. All right, notice how this one doesn't freak out. Cool, right? Anybody mentions the new camera, again, remind me and I will give you credit, extra credit. Let me see. And then GF, so the other side of that guy is, let me try to write it this way. I know it'll be weird, and I'm sorry. 8x minus 8, I think is what, yeah. So notice these two have those congruent symbols. So this is congruent to this. So let's write that. Let's just sometimes I get in the habit of not writing all this stuff out. So for the measure of angle BGC is congruent, and we're about to start in module 3 proofs, so you guys will get used to writing a little bit. So they're congruent, so the measures are wait a minute, no, the measures are equal, so it's actually the angles are congruent, because remember, the shape is congruent. Congruency is about shapes. Equal is about numbers, okay? So the shapes are equal. I'm sorry, the angles are congruent. The measures of the angle are equal. Just try to be super official here for a minute. And now we just plug in. So measure of angle GCB, 7x. And maybe this will help some of you guys. Again, this is kind of going to kind of help us correct a few mistakes. I'm hoping you guys we're going to watch the video. I'm not going to say I'm going to make you. But I am going to highly suggest it or make something. So, yeah. Speaking of which, if I'm asked you to watch this video because of on the test trying to help your performance, I may ask you what you got out of the video. You need to please be able to tell me that you heard me saying this. I don't know. Well, again, just trying to help you guys. All right, so over here, 7x minus 7x is 0. So that's gone. Negative 2 comes down, equal comes down. 8x minus 7x is x, and then the negative 8 comes down. Okay. Again, I'm doing some extra stuff because some of us need a little extra. So, you guys need to fast forward or whatever. Do what you need to do. I said this is for everybody, and everybody learns different. So now we have negative 2 equals x minus 8. All right, so what's my next step? I want to get x by itself. So it's a negative 8, so we're going to add 8. So weird. 8s are not my thing, man. All right, so negative 2 plus a positive 8 is going to be a positive 6. Equals comes down. X comes down. Negative 8 and positive 8 makes 0. So this is gone. I just do that. So you have left is x equals 6. All right, but what did they ask for? They want to know what BGF, the measure of BGF. All right, so a couple of ways I'm going to show you this. I'm going to show you the official geometry way, which I've been lacking on in some cases, because I want to show you guys the easy way, but I forget we really have to establish this writing stuff. So BGF, that's this whole angle. So they want to know the whole thing. So now there's a couple of ways we can think about this. So angle BGF equals, so it equals 7x minus 2 plus 8x minus 8. So we can plug that in and do it that way, because it equals BGC and CGF. But another thing to think about is both of these equal the same thing, so you could just say, because it bisects it, remember, it cuts it into 2 equal pieces. So we could just plug in 6 for x, but say, here, I'll just show both options. So your options are that BGF equals, and it's supposed to be the measure, but we're having, fine, I'll write it, fine. I'll do the right thing. So BGF equals BGC plus CGF. So CGF. All right, so that's the long way. And let me glare on the pencil. So another way measure of angle BGF equals, didn't put it there, but so the measure of both of these angles, but it also equals 2 times the measure of either one of these angles. So 2 times 7x minus 2, or I meant to, yeah, actually let me write this over here. So measure of BGF equals 2 times the measure of angle, and I plugged in BGC. Excuse me. All right, so over on the side here, let's just plug in 6 for x. So 7x minus 2. So 7 times 6 minus 2. 7 times 6 is 42 minus 2. So 42 minus 2 is 40. All right, so if I take this 6 and if I plugged it in here, so if you have your calculator, 8 times 6 is 48. 48 minus 8 is also 40. So like I said, they're equal. So in this case, it's really 2 times 40. So the answer is 80, but let's plug it in right here in this. So hold on a second. Let's see something. Hang on. Yeah, let's just, do this. So it's not a distributive thing because we don't want to distribute this. Just watch. We're going to plug in our x inside here. So 7 times, because that is, please excuse my dear Aunt Sally. So please, the parentheses first. Now you distribute it when this is a variable because we don't know, but we know this. So we're not going to distribute. We're going to say we're going to do it like this. And I hope this will help some of you guys. So 7 times 6 again is 42 minus 2. So we'll just scoot it over here 2 times. 40 minus 2 is 40. 2 times 40 is 80. So, see why we didn't distribute it if we had. So, you get this right. 2 times 7x is 14x. So, that would be this, but you're going to say 2 times negative 2 is going to be negative 4. So, you end up with 42 minus 4. So, you're wrong because you distributed that and you didn't need to. Excuse me. Okay, let's flip over. This video is getting long, so yeah. How many pages? 1, 2, 3, 4, 5. Yeah, this one actually is a little over 6 pages. So yeah, I'm gonna do like 3 of these pages, and then I'll do part 2 tomorrow. It is almost 11 o'clock on Friday night, and I'm tired. Been a long week. So number 4 says that in the diagram, AB and EC are perpendicular. All right, so what do you guys remember about perpendicular? I hope you remember that perpendicular lines are usually shown like this, and that you know what this box means. That box means it's a 90-degree angle. So perpendicular means 90. So down here when we're talking about all this, so we have a box over here, but the other side has a box. Why? Because this straight line is 180. Let me just do this. So all the way from here to here, that's half a circle, right? That's 180 degrees. $90 for the box. 90 for the box. 90 and 90. Man, it's always a good idea until you write it down and you can't see. So here to here is 180. This is 90. This is 90. All right. So get down here. HEB. So HEB is 9x. So let's just say 9x. And then CEH. So the other side is 13x.2. I'm sorry, 13x minus 2. Again, long day. Plus 2. Oh, again, long day. So value of x is blank and the value of HEB. So we're going to find x and then we're going to plug it in for this. So they're not asking about the others. All right, so I know, see, this box covers both of these angles. Let me just, so that means, and so I said perpendicular 90. So if I'm writing my equation, I already write 90 equals. So it's going to be 9x plus 13x plus 2. So, and this is where I've messed you guys up. I get straight into that. Let me go up here and write this correctly. So 90 equals angle HEB plus angle CEH. Oh, goodness. Love when I do that. Okay, so these equal 90 because they're perpendicular, this angle and this angle. So we plug those in. HEB is 9x. CEH is 13x minus 2, plus 2. God. So we put all this equal to 90 because those two angles, this angle plus this angle equals 90. Now let's solve. All right, so first thing we're going to do, we have a guy with an orange and a guy with an orange, so we can add those two together. 9x plus 13x is 22x. My plus 2 is coming down because nothing happened to it. The 90 is going to come down because we didn't do anything. All right, so now we have this. So x was with 22. The plus 2 over here, I need to get rid of it. So minus 2. Minus 2. So 2 minus 2 is 0, so it's gone. 22x comes down because we didn't touch it. Equals comes down. Now over here, 90 minus 2 is 88. Oops, 88. Okay, so, all right, so now we have 88 equals 22x. So we need to, this is multiplied 22 times x, so we need to divide. We do the opposite. So these cancel over here. 88 divided by 22 is 4. So let me just write that over here. Not 4. Wait a minute. That's not right. Hold on. It's way too late at night. No, it is 4. Sorry. That's right. Yeah, x is 4. So, yeah, trust the math sometimes. Okay, so x is 4. Now they want to know HEB. So angle HEB equals 9x. So that equals 9 times 4 because x equals 4, right? 9 times 4 is 36. So angle HEB is 36. So we can write 36 in here. If I can write a better 6. There we go. Scooching up the page. All right, so number 5. So let's read the problem first. All right, so two angles are complementary. Hopefully you remember. I'm sorry, coloring it in because it's important. So hopefully you remember complementary starts with a C. Oh, off the page. So complementary starts with a C. It means that these two angles equal 90. So it's kind of like perpendicular, but it's just two angles that equal 90. Supplementary, that's the other word, starts with an S. It means 180. So let me just put this to the side. And what I've been telling folks. So C is earlier in the alphabet, so that's the lower number. C is complementary, that's 90. S is further in the alphabet, so that's the 180. Hopefully that helps you remember. All right. Also remember, if you've watched or paid attention in class, 99 times out of 100, when we have these word problems that has a larger and a smaller, whether it's an angle or a line segment or whatever, smaller is going to be X. So let me just go ahead and start setting that up here. So complementary, two of them equal 90. So 90 equals. The smaller guy is going to be x, so we're going to put x plus. Now remember, the rest of this is using the smaller angle to describe the larger angle. So we're going to use some English here. So I'm going to put another x over here because whatever this is, it's going to be we're describing it to the smaller angle. So let's look. The measure of the larger angle, so this guy is less, wait a minute, 14 degrees less. So what is 14 less? 14 less is minus 14, right? So minus 14, whoops, 14. Okay, and then it says 3 times. Well, this is the smaller angle. 3 times the smaller angle would be what? 3x, because it's 3 times, okay? So smaller angle is x, bigger angle is 3x minus 14, because it said the measure of the larger angle is 14 degrees less than 3 times the measure of the smaller angle. So the x's, it's an unknown number. That's all we're doing. We're finding an unknown number. Now here we have an x and an x. We have 2 guys each holding an orange. 1 plus 3. So 1 plus 3 is 4x. Negative 14 comes down. We didn't bother him. These are together, so they came together. This came down. The 90 comes down. All right, so now we have 90 equals 4x minus 14. Switch to the red pen. Let's see if it's okay. All right, so we want x by itself. This is not a pen, but a pencil. That's okay. So getting rid of the 14, it's a negative 14, so we got to do positive, right? Positive, positive. Got a little bit of space, but I'm going to move this over here. So we're just going to do... All right, so 90 plus 14 is 104. The equal sign. All right, 4x came down because we didn't touch him. Negative 14 and positive 14 make 0, so those are gone. So this is what we have left. So now we want to divide both sides by 4. The 4's cancel here. The equals comes down, so it's x equals, and then we're going to take our calculator. I'm going to start using that in here a little more. So 104 divided by 4. Wait a minute. 104. 26. I was like, man, what in the world? All right, so the smaller angle was x, right? So it equals 26. All right, so the larger angle, we can either plug this in, or because we have 2 angles that equal 90, so 2 angles equal 90, one of them's 26, so they both equal 90. Subtract the one we know, that's 26, and we'll find our other unknown number, which is going to be, is that 26? Yeah, so it'll be 64. But just for giggles, so you guys can see it on the calculator, so 3x minus 14. Remember, 14 less than 3 times. So 3 times 26 equals minus 14, 64, and 64. So there you go. All right, let's do one more. That will be the first 2 pages, and then I'll finish the rest in the next video. It's, like I said, it's pretty late, and this one's already 38 minutes, so even I can't keep my own attention that long. So, all right, down here, number 6. Which statement cannot be assumed by the diagram? So cannot be assumed. All right, well, let's look at these things, and I'll use a pencil, and then we'll use a pen to finalize things. So, all right, it says GBE and DCB, DBC, excuse me. Now notice both are B in the middle. Thought I had the yellow pencil in my hand for a second. B in the middle. That means that it's this vertex, okay? It says this, they're adjacent. What does adjacent mean? You said next to. Give yourself extra points. You give yourself. I didn't say I was, but, you know. So adjacent or next to each other. Okay. It's okay. Are you leaving? Oh, you're just shutting the door. Okay. Yeah, sorry. Sadie's in here with me. All right, so GBE. So let's go GBE. So and I'm gonna kind of go a little to the side of the line because we may color one line more than one time. Oops. So didn't mean to go that far off of it. But GBE and DBC. So DBC. Sorry, though D to B to C. So we're, you know, if it helps you guys to do this color like D, B, C, then you see what you're looking at. So you see both of these are blue and they're next to each other, right? So yes, that's a good one. All right, so next, find a different color. All right, so BDC and FDE. So again, D, so this is right here. Let's see what we're saying. So FDE, so this guy. FDE, this guy. And BDC, so BD. Oh, BDC. Oops. This side of the thing. So it says they're vertical. Well, remember vertical angles. So vertical angles are the ones like this where the top and bottom, left and right. So these two are like these two. So that is a big fat yes. What is the deal, man? All right. So EDF and EDC. So we're over here again. So EDF. So that's FDE, EDF are the same thing. So, but we're going to make them orange this time. So we're talking about the orange here. So where am I looking at? Oh, heck, it's, well, yeah, EDF. Sorry, I'm confusing myself. And EDC. So EDC. Those are supplementary. All right, well, let's do the little line tests. The two orange, would they make up a whole line? So all from here all the way here? Yes. Because it goes here all the way here. Hope you see the half moon. So that would be a yes. Okay, and lastly, let's use green. All right, so ABG and GBD. So again, over here at B. So A, BG, so right here, ABG. So ABG. And GBD. So G to B to D. And it's on this side because G's on this side. If you're wondering, this would be DBC. So this is GBC, this side of the line. I know there could be some confusion over that, so I'm hoping maybe this will help. All right, so now, what does it say? They're supplementary. So let's do the line test. So let's see. Let me think about this. It doesn't go past there. It stops there. Wait a minute. No, because if, dang it, I don't have a freaking, let's do this. So if that line kept going, these two would not make the whole half circle. It stops here. So that is a big fat no. Okay. That is it for this. I will post part 2 tomorrow. Until next time, have a good night.